I guess that's how it goes. This is quite a common kind of problem in math contests. So it's asking, you have a circle. It's a unit circle. So what is a unit circle? It means that the radius is r. The radius r is equal to 1. Because it's a unit, right? 1. And you're trying to find the smallest triangle that will completely encompass the unit circle. So like you could have a triangle that looks like this. And you know, this would completely cover the unit circle. But you're trying to find the smallest area of the triangle that will encompass this unit circle. So this is obviously not the most efficient. You could definitely make it smaller, right?
The radius equals 1?
Right? So you try to make it as small as possible, right? So then the question is what is the smallest area possible? Okay, so like what, I mean, I think like for these kinds of questions, you should just try it out, right? Try different kind of triangles, see how they work out. So, I mean, this triangle might be our smallest area, but we don't really know how to quantify the area right now. So, let's think about different kinds. Like if I had a triangle with a really small base, right? So like this is our base, and then it had a very high height, something that looked like this. You think this would have the smallest area? Of course not, right? This area is gigantic. So something that you kind of realize just by trying it out. And there's a rigorous way to prove it, but the way to prove it isn't even necessary because, I mean, this is a short answer test. You might want to prove it on your own time. But the idea is what you want to do is, like, there are two extremes, right? You could have a really high height, or you could have a really long width. So you could also have like a really short height, but then the width is really long, right? This obviously is not an efficient way of making a triangle either. So the most efficient way, you would think, is to make it equilateral. So what does equilateral mean? It means each of the sides are the same. Yeah, and the angles are also the same. So now the question is given that it's equilateral, like if I was sure it was equilateral, yeah, I'm just gonna erase this part. Then what's the area of this triangle, right? So there's a couple ways to solve this. I think the most general way a pretty simple way is like you take this line. Now this is the part where you might not have seen it before. We have to use something called a 30, 60, 90 triangle. Oh, have you heard of it before? Okay, yeah. This is a pretty common one. It basically, like this is a very special triangle in a way because for a general 30, 60, 90 triangle, so when I say 30, 60, 90, I mean like the angles, right? So we have a 30-degree angle, a 60-degree angle, and a 90-degree angle, which we denote with just like the ball. The side lengths are in a specific ratio all the time. And like this ratio will be the same no matter what, as long as these angles are the same. So the ratio is 1, square root 3, and 2. So the hypotenuse is 2, and the smallest one is 1, and the longer length is square root 3. Is that fair? Like, does this look familiar? Okay. Well, it's a bit complicated, but anyways, the next idea is like, well, there's a way to prove this. I'll leave this to yourself, but what you'll see is like this length is the same, and the height of the triangle will end up being 3 times the radius of the circle. So maybe I should draw it again, just because it looks a bit ugly right now. That's actually good. Drawing diagrams is really hard.
Exactly. I was thinking your boyfriend is doing this to me. Well, wait, I got girlfriend. That was boyfriend?
That's small. So if the height, so like, do you know the area of a triangle? Like, how do you find the area of a triangle? Base times height over 2. Exactly. So we know the height is 3, right? So now we have to know the base. This is where we use the 30, 60, 90 triangle. So you know the side lengths are in this ratio. And you know the height, which is this longer length right now, is 3. So now you have to basically figure out what's this. This is a ratio. Yeah, you would have to know this ratio. Oh, okay. So this is like, I can prove it quickly if you want. Yeah, I mean, the proof itself is a bit annoying. So like, the idea is like, you drop this altitude right here. These are the same, right? That's fair? Okay. So, since these are the same, this is still a 30, 60, 90 triangle.
Okay.
Can you see that?
Yeah.
Okay. So, from there, we know that this is 2 times this, right?
Okay.
And this is the radius. So this is 2 times the radius. So like, oh, I guess that's not a very common. Okay. Anyway, my bad. I should have shown. So then, we want to make this equal to the same thing. So we divide it by root 3. And what we get is that this length should be root 3. Right? And this should be 2. So what is the area of the triangle at that point?
10.
It would be 2 root 3 times 3 over 2,
So 10.
which is 3.
Impossible.
Does that make sense?
Not really.
Like, is there a specific part that you got lost? I mean, yeah, like if you don't know, if you're not familiar with the 30, 60, 90 triangle part, it's a little bit complicated, but I mean, that's part of math. Alright, so the next one.